Hello. In this segment, we're going to be talking about buses. If you'll recall from our previous discussion on the detailed architecture of the little man computer, we had a lot of control signals that controlled access to a bus. Well, what is a bus? A bus is basically a collection of lines. A line is a single conductor carrying an electrical signal between components. And this one single line carries one bit of information. It's a voltage. It's either high or low, 5 volts or 0 volts. A bus, then, is a collection of lines that's used to transfer multiple bits of information at a time. So this is in parallel as opposed to in serial. The width of the bus, then, is the number of lines. So in this illustration here, what we see is two different ways of representing a 16-bit bus. Buses can come in two different flavors. They can be point-to-point buses, which connect only two components, or they can be multi-point buses that connect more than two components. In the little man computer, the bus that we saw was a multi-point bus. Buses that connect more than one component, or buses that can flow both directions between two components, but not at the same time, can have contention. A simplex bus can only transmit in a single direction. And so this is very simple. There's no contention. One person reads, the other person writes. A half-duplex bus can transmit in two directions, but not simultaneously. So one component can read at one time while the other component writes. One component then writes while the other component reads. But they have to control access to the bus so that they're not both trying to write or read at the same time. Full duplex buses can transmit in both directions at the same time, but this usually involves doubling the number of lines that we have. So if buses are not full duplex, then a protocol has to control access to prevent a collision on the bus where two components try and write at the same time. Two typical collision or contention algorithms are carrier sense multiple access with collision detection, which is what you find on IEEE 802.3 Ethernet. It detects a collision and then it backs off and tries to retransmit it another time. Or CSMA-CA, that's collision avoidance, that we find on Wi-Fi. In this, you first request access to the bus, then once you receive permission, you can transmit on the bus. And so there's a master controller that controls access to that particular bus. In summary, buses carry data from one component to another. The width of the bus determines the number of bits at a time that can be transmitted. When a bus is either half-duplex or is multi-point, then an algorithm is needed to control access to the bus to prevent collisions.